Okay, hello YouTube. I'm here today. I'm going to go over the device I just got, which is a little PCB that I ordered from Kickstarter some time ago. It looks pretty nice. It's the HamShield, which allows you to transmit on 2 meters, 70 centimeters, and 220 megahertz ham bands. You should have a license, or you have to have a license to use this. And I bought the basic kit. It comes with a board. Great communication, by the way. I have no complaints about this Kickstarter. Comes with the board, which looks well thought out, and then two things that probably couldn't be pick and placed or automatically assembled. One is the big SIP header strip, and then there's a little SMA connector that straddles the side of the board like a lot of modern things do. It goes on the side here. So it looks like they did everything they could in assembly, and then they left just a little bit of soldering for us. So I thought that'd be interesting to show how to solder that SMA connector. In addition to this stuff, it came with a antenna and a little guide for the different bands to get good SWR, because it's got a loading coil, meaning it's nicely coupled or nicely matched. So there's rules for how many segments you should pop out. Now, one thing I noticed is that there's different widths or different lengths of the segments here. So some are short and some are long. Heard that before. And you know, it says put 2 segments in. I'm assuming it's the top 2. We can look it up to an SWR meter and actually see what the best setting is. But this is a cool little device. There's probably quite a bit of engineering that went into it. Looks like sort of like a monolithic all-in-one chip, oscillator, some amplification stuff, and then a 3-pin headset and microphone board. The only thing I don't like about the board, and this is just sort of a pet peeve, you can definitely tell it's from China. If you look at it, you know, like this is straight, this side's cut relatively straight. This is all done by a shear. This side's pretty good, but this side is not so good. So you put it up on the side, it kind of wobbles. And if you look, it's going to be hard to see in the video, but the shearing that they did, this trace is straight, and the shearing that they did gets really close to that straight. So it would have been nice if they did that flat, although looking at it, it looks like everything's fine. Or not flat, but at a 90-degree right angle to the side. So you can tell it's not perfectly sheared from a big panel. That being said, it's not too bad. So I've got my soldering iron going here, and we're going to start by doing this little SMA thing, because I thought that would be the most interesting. Alright, I have the little SMA guy out here, and I'm going to put some flux. This thing is some type of chrome or something like that. I apologize for the noise in the background. That's the soldering iron. Seems like you can't turn off on this. You have one of those, you know, hot air systems, and you can't really turn off the air pump even if you're not going to use it. So this is old flux, but let me get some flux on there, just because again it's chromed or something, plated with something, and that's sometimes a little hard to solder on. And I'm going to try to do this with just a low wattage soldering iron that everybody would have, then maybe a little bit on these gold pads. So you see there's two connectors here, 2 connectors here, and then a middle. The outside is going to be the shield of the SMA. Can't really say ground because, you know, there's reverse polarity SMA. And then this is signal, and the antenna that they ship is also SMA. You know, I'd rather have it be B and C, but maybe there's a mechanical reason for that, or I'm sure, or they might not even make a B and C connector that straddles the edge of a board like that. So again, they're just having us solder the things that they couldn't do with pick and place during assembly. So if we look at this, get this out of the way. This little guy. And I wish I could zoom closer, but I can't. So this little guy actually fits on there pretty well. It'd be nice, you know, if there's a little bit more friction, it'd be cool. I think I can hold it just like that. Okay, so I took the little SMA connector. Well, I warmed up the soldering iron. I start off with a kind of a hot air system that I don't know. It's got a very small tip on it. That was junk. You need some wattage with some thermal capacity to solder this thing, since you're heating up not just the pad on the board, but the whole SMA connector. Even though it's not real big, you got to keep it warm enough to get a good, not a cold joint on it. So I jammed a little SMA connector on there and pinched it a little bit, and now it's going to stay on there so we don't have to hold it. You could use one of those third-hand devices with the alligator clips, but no need. So we're just going to do this like you would if all you had is a kitchen table and a Radio Shack soldering iron and some Radio Shack solder. I did put a little flux on there. It's ancient flux though, so it probably does absolutely nothing. And please, please, please use the real, I don't know if you can see that, real lead solder. I mean, if you're doing stuff as a hobbyist, I mean, come on. The green stuff, I don't know, it's awful to solder with, especially surface mount. So if you can get it where you live, switch to the lead. It's fantastic, and I was before ROHS, so I'm going to stick with the lead. So let's see if we have a hot enough soldering iron. I'm going to just clean the tip a little bit, and it's not the prettiest tip in the world, but it's going to do the job. There's some crap on there. Normally I'd have a fan on, but you can't hear me over the fan, so the fan's off. So let's see if we can solder this here. Again, we want to make sure we heat it up enough that you're not melting the solder with the iron, but with the device that you're actually soldering. So it'll take a second to get warmed up. Who knows if the flux is working? We want a nice, oh yeah, a nice joint, and that is a nice joint. It's not, yeah, that's really good. So I'll inspect that under magnifying glass. And the connector moved a little bit, but I don't know, this is greater than a 0.1 inch pitch, so who cares? Let's heat that up. And if I drive the solder into the SMA connector itself, you can, it's what's melting the solder. So I'm getting it on the connector, and then the connector's probably heating the pad. Alright, that's cool. And then you can tell actually that those are grounds. This isn't an RP, or reverse polarity SMA. You can see the little thermal reliefs around there. And so the signal is on the center pin, unlike some Wi-Fi stuff. So let's heat that up for a second, and then, oh, look at that, it flows in like you're sweating a pipe. So I think the flux did help. And then we'll repeat for the other side, which only has 2 pins. So 3 pins on the top because it's a single pin in the center, and be liberal with the solder because it's a mechanical connection as well. Okay, next we'll do the SIP, the silly Arduino mistake headers. Alright, okay, so the instructions say, put it on a Arduino and use that as a template, or use that to hold your pins. Nah, we don't need to do that. Why follow the instructions? Also, the straddle mount SMA connectors, freaking solid, man. So, if you put the antenna on there, which I've already lost, there it is. I'm a little less worried about it than I was. And there's no flex, so cool. All right, let's put these connectors on. Now we want these to come in from the bottom, so it has some. Well, yeah, obviously just coming from the bottom because that's what we care about. And let's see now, the Arduino people, early on, most of these things are on, or this is a 0.1 inch spacing or 2.5 millimeters for the civilized world. Unfortunately, one side is off by 0.05 or 50 thousandths of an inch. It's using a GUI to lay out a circuit board. And just dragged it and never noticed it, and now that's the standard, so yay. So let's get some pliers, and we're going to, let's just see here, how many do we need? I'm not going to count, I'm just going to shove them in there. So this is the first cut, just oops, do it that way. flew away. Okay, now we'll flip that around. And these things usually have enough tension that you can just solder them in. So tack down one thing on each side and go from there. Maybe that's not the one to start with. Okay, again, we want to heat up the pad and the header pin. Not too much, because you'll melt that plastic. And come on, I did not put flux on this. So it's get that in there. It's a good joint. Let's just check it's flush. And straighten it out a little bit. And then do this side. It's a little more difficult because it's right next to the switch. Okay. So far so good. I kind of pop around, you know, if you're soldering some type of component, it's good to move around from side to side, just so you don't heat up, well, you're going to change components, so you don't heat up the neighboring component, or you don't heat up the same area of the component, you don't heat up only one component. That doesn't really matter for this connector, but it's a habit. Maybe it helps with mechanical alignment, I don't know. Things change size when they get hot, and when one side of them gets hot, they warp. Alright. That middle one could probably use just a little bit more. I shouldn't be using this big soldering iron anymore, but it shows that you could use something for wood carving almost to put together the rest of your kit. And just a quick look under the magnifying glass for me. No bridges, no cold joints. So maybe you can see, I don't know if you can see, that's as close as I could focus. So there's the first header. I'll do the other ones and then probably speed it up in the video. I'm not sure if it's supposed to actually help because those if you know, jewelers know something about it. Alright, so we've got the SMA connector on there, we've got the header pins. So this is a crappy, I think, knockoff Uno, but it will certainly fit for a test. Oops. Alright, there we go. Now, I noticed on this one that the, let me see if I can focus that a little better. It's actually pretty close to, or this USB connector is right underneath this other, and I'll focus again, is right by this header. And I don't even know what that is. I mean, it's like some kind of 8-pin port. It might be just a duplication of something from the main board. And there's this little thing for just audio, but yeah, I'm not sure it would work real well with this board. I'll put the macro on so you can look at the board closely. Again, subscribe below. There's some interesting stuff in the works.